Hello and welcome back to Podcast School. This is another look at logic. In fact, this is logic part 2. It follows on from the last video podcast. Okay, so this podcast is going to concern questions. It's going to have more questions in it rather than facts like the last podcast did. So if you haven't already looked at the last podcast, then go back and review that because you'll need the information that contained in order to look at these questions. So let's start off by looking at question 4. It says, a metal cutting machine has 2 switches. Any one will allow the cutter to run. The first switch is on the side of the machine and the second is a foot operated switch. Okay, notice it says any one will allow the cutter to run. However, the machine has 2 micro switches used as safety devices. If any of these is released, the cutter will stop. If any of these is released, the cutter will stop. The first micro switch is on a guard. If this is opened, the machine will stop. The second micro switch is on a door, which allows access to the moving mechanism of the milling machine. If this is opened, the machine will stop. In other words, if either of them are opened, then the machine will stop. Okay. The other little piece of information you need to know is the micro switches are normally logic 1, true, high, on, when pressed. Draw the logic diagram for this machine. Okay, now I'm not going to dwell on this. I'm just going to show the answer right now. So if you want to have a time to think about this, well, then you should press your pause button just now. Okay, so I assume now you've unpaused. So let's have a look at the answer. There you have it. You've got, well, first of all, the on-off switches. I said that either of those will make the machine start. So we've got an OR gate. Okay, remember we're building this up in logic. So OR, so A or B. All right. And also, as well as that, there were 2 micro switches. And I said that if one of those is released, then the machine will also stop, or will stop. Okay, so if you think about that, if C and D were both 1 when pressed, that would give a 1 output here. Okay, if either one of those, if the door was opened or whatever, the switch would no longer be pressed and therefore you would have a 0 in one of them, depending on which one it was, and therefore you would get a 0 at the output. So you'd no longer have a 0, you'd no longer have a 1 at the input of this AND gate. So no matter what the OR switches were, or the OR input was, Q would be a 0. So the machine would go off, and that's what you want. Okay. In other words, that describes completely the function that we need. And in fact, that is the answer. Okay, so I hope you got that. Now, following on from that, it says the room has 2 emergency stop buttons at either end of the workshop. So these are additional safety devices. If either of these are pressed, all machinery in the room will stop. Draw the new logic circuit for the arrangement of the buttons and switches. Okay, so obviously this answer is going to incorporate the first answer plus a little bit extra. Again, I'm about to show the answer. If you want to pause it now, do so. Okay, here it is. Okay, same as before, but this time we are looking for 2 emergency switches at either side of the room. Okay, so those are inputs. We input those into an OR gate. I've showed this as a NOT gate or an inverter, but I know that you know now that if we wanted to combine that into one logic gate, that would just be a NOR. Okay, so a NOR in other words, and then again input to an AND. Alright, so I hope you got that. If you didn't, then well, have a think, and I'm sure that you will reach the same conclusion as I did. Next question. Simplify this combinational logic. Now that can look quite daunting, and there was a question similar to this in the last podcast, and what I said there was sometimes you might not see labels given in the middle of the combinational logic. You might just have A and B as inputs and Q as an output. What you should definitely do is just add any labels that you need to add in. And I said that I normally add a C, or following on from the letters, in other words, to the right hand side of the input, but onto the left hand side of the output, I normally use the sort of the latter part of the alphabet. So I use X or Y or Z just to denote that's near the output. Don't know why, actually. Maybe it's just something I do. Maybe it's a bit strange, I don't know, but that's what I do. Okay, so let's see how we do this. I've got the diagram again, and I've filled out A and B. And remember, in the last podcast, I said that your inputs should always be 0, 0, 0, 1, 1, 1, and I explained that, and 1, 0. Standard way of doing things. And really, it's easy after this. All you got to do now is fill out the table. So let's look. C is the output simply of a NAND, so we can fill that in straight away. Okay, as so. Notice the only time that it's not a 1, the output is not a 1 at C, is when the input is a 1 and a 1, opposite to an AND. Okay, the X input or output, depends what way you want to look at it, the X state is conditional on A and C. So really what we're looking at is column A and column C. So we're ignoring B for the time being. So it's a NAND gate again. So a 0 and a 1 will give us a 1. A 0 and a 1 again will give us a 1. A 1 and a 0. So I'm looking here and here. Well, gives a 1. And a 1 and a 0. A 1 and a 1 will give us a 0. Okay, so that's X got. Now all we've got to do is get Y. So for Y, we're looking at, B and C. So it's these two columns we're looking at this time. So a Y then, or let's go for Y. So 0 and a 1 will give us a 1. A 1 and a 1 will give us a 0. A 1 and a 1, again, will give us a, 1 and a 0 will give us a 1. And a 0 and a 1 will give us a 1. Okay, again, just using the basic NAND truth table to work that out. Now, what's left? Q, and again Q is the result of X and Y with the NAND function. So let's just go through that. A 1 and a 1, a 0, a 1 and a 0 is a 1, a 1 and a 1 is a 0, and a 0 and a 1 is a 1. Okay, now question is, what does that logic simplify to? So I've highlighted the inputs and the outputs. Okay, so really, forget about C, X and Y for now. Really, if this was a black box and these were two wires going in, well, we'd only see A and B, and we'd only see Q coming out. So that's all we've got to concern ourselves with. So the output Q of this truth table is 0, 1, 0, 1. And I know you've seen that before, and you've probably got it by now. Yeah, this is an exclusive OR gate. Remember, it'll only give you a 1 when the input is a 0 and a 1. And unlike a normal OR gate, it gives you a 0 whenever the inputs is a 1 and a 1. So that's the strange one there. Anyway, it's an exclusive OR. Okay, lastly, I've just put a note saying that it's not good practice to mix different logic ICs. This writing's a bit small, by the way, and if you're watching this online, actually on your browser, then it might not be just legible. Remember that you should always download the high quality version by subscribing to the feed through iTunes or any other reader that you want to subscribe with, because that higher quality version is available to you. And also remember you should be picking up the notes in the feed as well. So if you are finding this a little bit difficult, well then don't forget there's the other methods to pick this up. Anyway, what was I saying? Yeah, so I just said it's not a good idea to mix logic ICs, because if you've, as you know, you get ANDs and NANDs and ORs and NORs, you get them in groups of 4. So if you didn't need all 4, say you only needed 2, well then that's wasted space on your circuit, right, in your circuit board, and you try not to do that. So it's best to keep your logic circuits all the same. So there's a big advantage in not mixing your logic circuits and building all your functions just with the one logic type. So it makes sense to try and stick to NANDs, for example. And I've shown, in fact, a NOT, an AND, an OR, an exclusive OR, all made there with NAND gates. Okay, that's it for now. I shall see you next time. Don't forget, you can email me at info@podcastschool. And as I said before, if you haven't done so, pick up the PDF notes. And if you've subscribed in iTunes, just always make sure that you've got all the video podcasts. Sometimes if you haven't logged on for a while, you can miss one. if you've because iTunes is set up normally to only download automatically the last one, so if it's been a day or two you may have missed one, so just make sure you're getting all of these in your feed. Okay then, until next time, bye bye.